Last example for this asymptote domain range video, let's crack it. Looking at this new function, f of x is equals to 3x plus 3 over x minus 8. We're going to start tackling this first by talking about the domain and the vertical asymptote, easiest fruit to pick off that tree. So let's ask ourselves, well, this equation or this function is only going to break when the denominator is equal to 0. So let's just set that equal to 0 for a second, and maybe we can really quickly see that when x is equal to 8, 8 minus 8 is 0, that breaks the function. So the domain for this function is all real values of x, except such that x does not equal to 8. Nice. There's the domain. Nice and quick. And immediately we see here that the vertical asymptote is just going to be the equation for the x value that the domain doesn't exist or isn't defined. So the vertical asymptote is such that x is equal to 8. Bang. Alrighty, that's like 4 marks in an IB exam usually, or maybe 3. And we'll talk about specific exams and marks later on. Now let's do the range and the horizontal asymptotes. For this one, it's a little bit trickier. Remember what we said for example number 2. The powers for the x values, if there are x values on the top and bottom, really make a big difference. So in this case, let's rewrite our function a little bit bigger down here. We have an x value on the top and an x value on the bottom. And in this case, they're both going to be the same power. Notice that they're both technically raised to the power of 1. That's pretty interesting because that means that if they're both raised to the same power, they're both going to be increasing and decreasing at the same rate. If you have an x cubed on top and an x on the bottom, the cube one is going to be increasing way quicker because it's increasing at 3 times the x, basically. Not really, but close enough. In this case, though, x to the first power on top and x to the first power on the bottom, they're both increasing and decreasing at the same rate. So that makes our lives pretty interesting, though, because when we say, well, what happens when x gets really, really big or really, really small? They're basically going to be increasing to those really, really big numbers at the same time, or at the same rate. And what happens? Well, they basically cancel each other out. And when they cancel each other out, like let's rewrite this as 3 times something big over just something big. When something big and something big both are dividing each other out, they basically cancel each other out, right? So what are we left with? We're literally only left with the coefficient. We're left with the ratio of the coefficients between the two of them. So in this case, when we look at the range of values for y, what is y going to be equal to? Well, it's going to eventually, or the asymptote, when we're looking at, well, what's that horizontal asymptote eventually going to approximate? As x gets really, really big, they cancel each other out. So y, eventually is going to be equal to, but not quite equal to 3. That tells us, if that's the horizontal asymptote, easiest one to figure out, the range of y values that work for this, y, is going to be equal to all real numbers, except such that y does not equal to 3. So the big lesson we're learning here is when we're figuring out the vertical asymptote, if the powers on the top and bottom of the fraction are the same, you're always just going to take a ratio of the coefficients. And in this case, 3 divided by 1, there's a 3. There's a hidden 1 coefficient there. That's a really ugly one. That's better. Gives us 3. That ratio of the coefficients, when the x powers are the same, gives us the horizontal asymptote, and that also gives us the range for y. Notice how they're they go hand in hand. It's nice, huh? To summarize, how do we approach these kind of problems moving forward? For the domain and for the vertical asymptotes, ask yourselves, what are the forbidden values that x is not allowed to be equal to? Very often, for the IB, this is going to be that you have or some kind of function that has a fractional form where there's an x component in the denominator, and that x component is not allowed to be equal to 0, or the denominator is not allowed to be equal to 0. So you figure out what x value makes the denominator equal to 0. Usually. Not always the case. We can have other forms of functions like trig functions that have different implications, but for the general purpose of the functions unit, Usually it's going to be the denominator. That's already going to tell you what x value is not allowed to be equal to, the domain, and then the vertical asymptote, the equation for that specific value. Easy peasy. The range and horizontal asymptotes are a little bit trickier, but not too bad. The question you're asking yourself here is what happens when the function gets really, really big or really, really small, or the x values get really small? What happens to the y values or the output? If you don't want to really keep asking yourself this question or think about this too kind of theoretically or abstract, the easiest way to do this is, okay, just to look at the function and say, if it's in this fractional form, right? Let's say you've got x to the a over x to the b. So you've got two x values on the top and on the bottom. If you're in a situation of we have a function like this, in fact, you know what? Let's write in f of x is equal to this. And then they're just, plus two different constants. Doesn't really matter where they are. The thing that we're going to be most interested in is those exponents. If the bottom one, b, is bigger than a, in other words, the x power on the bottom of your function is bigger than the top one, then always, 100% of the time, this function is going to have, or it's going to, the horizontal asymptote, there we go, the horizontal asymptote is going to have the equation y is equal to 0. That's like guaranteed to be the case because it's going to eventually approximate 0. That's a fancy way of saying it's going to like curve and touch 0, but not quite actually get there. That said, let's change to white. If a is equal to b, in other words, they have the same power, then the equation for the horizontal asymptote is just going to be a ratio of the two coefficients. So why don't we go ahead and add some coefficients in here, m and n. Then the equation for the horizontal asymptote is going to be equal to m divided by n. Literally just taking a ratio of the two numbers, the two coefficients in front of that x. Those are the two real base cases you need to think about. The other base cases aren't really going to, there's nothing else I can really ask you when it comes to this. So it's pretty simple. What are the forbidden x values? Usually the denominator of fraction will help you approximate those. Then with the function, does it have two x values on the top and bottom? If so, is the bottom one bigger? Then it's going to be 0. If the top one is the same as the bottom one, it's just going to be a ratio of their coefficients. That's it. We'll do some more actual exam prep questions and put this all together in the later videos of the series.